me show you how to be a good breezy and change your predictions after.
Hello, my dear Bayesians. You remember that a few weeks ago I sent you a survey to tell me what you would like to hear if I were to ever make live cohorts to, well, learn with you and also teach them. Well, this is now happening. If you want to learn Bayesian stats live with me, now is the time, because I am excited to do that in partnership with Athletics, and I'm going to be one of their early collaborator on their live feature. And this is a company with which I share a focus on applied hands-on learning, especially through sports case studies, where Bayesian methods, of course, shine. And this partnership with Athletics means a few things, but first it means short, live, code-first workshops with recordings and GitHub repo included. Thanks to Athletics, that means pre-authenticated Google Cloud virtual machines, so you can model without setup friction and without environment problems. That means sports analytics projects you can adapt to your team or your work, and of course an ongoing Q&A via my Learning Bayesian Statistics community. You will join the Discord with all the patrons if you are an alumni of the live cohorts. We're kicking this off with hierarchical models, what else, in PyMC on November 5 and 6, 2025. This will be 2 short sessions, 2 hours and a half, where you will build and interpret several working multi-level models with posterior checks and stakeholder-ready visuals. And you'll have, as I was saying, all the bells and whistles. I will put the links in the show notes for you to learn more and enroll if you want to. Of course, if you are a patron of the show, you have a 20% discount that I added in Patreon and the Discord, so make sure to paste the discount code at checkout. And I'm really looking forward to doing that first cohort and also to building more intensives if this pilot helps you deliver impact quickly. So please let me know in the comments, on LinkedIn, on Patreon, on Discord, wherever you can reach me. Please let me know what your favorite topics are and what you would like me to teach next time. I'm really looking forward to this. Thank you so much for being so excited about that, at least as excited as I am from what I've seen. So thank you so much for your support, and I can't wait to see you in this first cohort. And in the meantime, let's now dive into nutrition science with Christoph Bamberg. Do you remember what first drew you to Bayesian statistics and computational modeling in general?
Yeah. Funny that you say that I'm living proof that it's possible, because sometimes it was a bit of a struggle also with my co-authors to kind of convince them that it's worthwhile, because in psychology, unfortunately, it's not that common yet in many fields. But a colleague from the University of Auckland, David Moreau, with whom I published an article as part of my PhD, he recommended the statistical rethinking from Richard McElreath. Basically, in my first few weeks of the PhD, and then I started reading it. I think the first edition, watched the video lectures, then I got the second edition, watch the video lectures again, because I feel like it's good to come back to this book, because it's just very dense and very fun to read. And that's really my foundation for Bayesian statistics, I would say. And then I think, through the podcast, I also got to know the work of Andrew Gellerman, Aki Veteri, and who was the other author on regression and other stories?
I think it's Jessica Hallman you're talking about. Yeah.
And also read that book, and this is kind of the foundation of my Bayesian skills. Yeah.
Damn, pretty solid foundations. Especially the podcast part, I would say. This is a very solid source of information you've got here, Christoph.
I think I would say from listening and working on the podcast, I mostly took away more, less the practical things, but more kind of the behind the scenes, kind of how people shared their struggles with Bayesian statistics and
Right.
kind of the perspective on it. I think, that was good to listen to those conversations to kind of get an idea of that. Yeah, which I think is difficult in a book to
Right.
transport
Yeah,
this.
Yeah, for sure. Yeah. It's also why I'm making the podcast. So I wasn't fishing for compliments. That was a joke, but I definitely take the compliment.
Yeah. No, really. I mean, I think I started listening, at the beginning of my PhD when all of this was still quite new. And then it was just good to hear people who actually develop the methods also talk about how difficult it is for them, and to just see that they're also just human, right? That really gave me more confidence that I can also use Bayesian statistics.
Yeah. Yeah, that's a good point. Yeah, that's also why I love doing that. Is that you often feel alone and lost when you start learning something, or even like just when you model. Like modeling is an inherently hard endeavor. And especially Bayesian modeling, because a lot of the things are not working out of the box. That's kind of the idea. And so you have to customize everything, and that can be very intimidating. And so I think having people who are regarded as expert come on the show and saying that, no, I struggle too. It's just I'm more advanced on the learning curve than you are, but the struggle is still here. Don't worry. So this is very important, I think. And talking of struggles, do you remember actually what were the main obstacles you were encountering when talking with your co-authors, or even people now who I'm guessing are asking you, what is that whole Bayesian stats about? Maybe even reviewers. What was the kind of obstacles you had and that you apparently successfully overcame?
That's a good question. Well, regarding the reviewers, I must say I expected more obstacles, but I think the problem there is that in health psychology, there are just not many people using Bayesian statistics. So I also didn't get many comments regarding my methods, unfortunately, I would say. So I kind of had to go to colleagues and so on to make sure that a second pair of eye also looked at my Bayesian methods. So that maybe as a small side remark. The main obstacles, well, with my co-authors, it just seems like more work, and it oftentimes on the first glance, it leads to the same results. And then if that's the case, like if the coefficient in the regression model, frequentist or Bayesian, is more or less the same, why would you then put the extra work in? I think that was difficult to explain to my co-authors, that it just happens to be the case that the frequentist model also works, but the Bayesian one is actually better and kind of encompasses the frequentist results as well, right? And with my colleagues, so in my team, I'm more or less the only one who's really enthusiastically using Bayesian statistics. Some of my colleagues use it because the frequentist models fail, because we use complex multi-level models. There I think the struggle is kind of with the priors for some reason. So somehow some of my colleagues and also people I talk to are kind of stuck with this part, and kind of figuring out how to find reasonable priors. Even though I would say in the beginning that's not even so important, I would say, from my experience, right?
Yeah.
But
No, for sure. Like, it is funny that it's often something people overthink. And over-engineer at the beginning because it's not that important. And I mean, if it were, actually, I think if it were, frequentist models wouldn't work that well out of the box most of the time.
That's true.
Because like most of the time these priors are really stupid because they're completely wide and they allow for really, really weird results a priori, and they still work very well most of the time. So if priors were that important, everybody would be using Bayes actually. So,
that's true.
so yeah, so basically
think,
from what you're saying, I hear that, the fact of having hierarchical models and scarce data was something that was very important in your motivation to use Bayesian stats. Is that correct?
I think right now it's one of the motivations I have to use it. Yeah, and just this ability to look at changes and effects within an individual, since we are doing psychological research, but then also get a good estimate of the population effects. Yeah, I think Bayesian statistics is just quite nice for that, especially for the kind of individual level predictions. I really like it because, yeah, I mean, if you use frequentist statistics, at some point you would need to bootstrap anyways, and then you might as well start with Bayesian statistics, right?
Yeah, no, for sure. I'm curious actually, which technical stack are you personally using when you're working on your models, and
sorry,
and also
you cut out for a second there.
Oh yeah, okay.
Could you repeat the question?
Yeah, no, for sure. I'm curious actually, which technical stack you're personally using when you're modeling for your papers and your studies, and also which technical stack do you see your colleagues pick up most of the time, and with which they have the best relationship as beginners, and why?
So my workflow is usually depending on the data, but if I need to do a lot of pre-processing, like with the cognitive tasks that I'm using, where I get data per trial and I need to aggregate that somehow, then I usually use Python and yeah, just kind of the standard Python libraries to pre-process it and then put it into a nice data frame. And then I switch to R. Yeah, I don't know whether that's a little bit hacky, but it works well. And in R, I usually use BRMS. Now I also, over the summer, I sat down and studied Stan a little bit more in detail, and I think I will, yeah, kind of switch to using that more in the future. But I usually start with BRMS, and yeah, just for the standard regression models, that's usually works quite well. And that's also what my colleagues use, because in psychology, we mostly use R and the, what is it called? The LME R or the LME4 package for multi-level modeling.
Yeah, LME4, I think, yeah.
Yeah. And yeah, that's just a similar syntax to BRMS. So the switch is actually quite easy to do. Basically, you just have to change a few letters and then you already have your Bayesian model.
Yeah, that makes sense. And definitely recommend BRMS for everybody. I will put in the show notes episode 35, which was with Paul Birkner, the founder of BRMS, and Paul is an extremely brilliant researcher, and definitely recommend checking out anything he's doing. Also a great person, so I will put that into the show notes. I will also put episode 112, which was with Tommy Capreto, who is the main developer of Bambi, which is the Python equivalent of BRMS for people who want to do that, but in Python, which I guess is an important language right now. I heard some people were using it from time to time, but I'm not sure. Actually, let's dig deeper into your research, Christoph, because you're actually doing research on topics I personally found super interesting. And actually, I will put also an episode in the show notes with Eric Traxler, who is a researcher in this field, who does very interesting work too. And I see these guys using more and more Bayesian stats, I think. So this is great. This definitely warranted, because they usually have experiments with like 10 to 30 people So you definitely want to use Bayesian stat with so low sample sizes. So you work a lot on appetite and appetite regulation, and how, I don't know if you work a lot on also the interaction with exercise, but I don't know you work a lot with the interaction with the psychology. So you had a recent paper about appetite that looks at how dietary claims affect cognition. So can you talk about the study, what motivated it, and what the main findings were?
Yeah. I really like this study because it's just fun to talk about this one. So the motivation was, maybe you know this saying that breakfast is the most important meal of the day, right? Like basically everyone knows it. And usually we would say, yeah, okay, that's based on the wisdom of our grandparents or something like this, right? But actually it's just an advertisement from 1917, I think, invented by a colleague of Kellogg's. So the Kellogg, the creator and inventor of the breakfast cereal, just to convince people that they need to eat more breakfast and buy his cereals. And when I found this out, I just found it very interesting, because I think this advertisement actually affected a lot of people and kind of their behavior and their beliefs. And I just wanted to see whether, this can also be found experimentally, and not just in their beliefs, but also in their performance, right? So the actual ability to concentrate. And so what we did there was, it was in collaboration with Anne Ruffs from the Maastricht University in the Netherlands. And what we did was we had half of the participants start the experiment when they were fasted. So they didn't eat for 16 hours. The other half had their regular breakfast and lunch. And then we split those two groups again, so that we have 4 different groups. And in the group that fasted, half of the participants who were fasted, they read a statement saying that fasting is good for concentration because it increases your seeking behavior, and that's important on a lot of cognitive tasks. So kind of framed as a scientific finding. Yeah. And the other half read a statement that fasting is bad for concentration because you're distracted by your hunger, and then you can't perform so well. And then in the satiated group, so those that ate, half of them had the statement that being full gives you energy so you can concentrate, or that being full takes energy to digest and then you can't concentrate. And then everyone did the same psychological task, the Simon task, where you have to press either one button or the other one, depending on where colorful squares are on the screen. And it's a little bit challenging because you have to inhibit your initial response based on the location, but focus on the color. And so you need to concentrate on that. And what we found was an interaction between the two manipulations, such that if you're hungry and you expect to perform better, the performance was actually objectively better than if you were hungry and you expected to perform worse. And the same in the group that was full. Yeah. So if you were full and you expected to perform better, you were better. If you were full and you thought you would perform worse, you also performed worse. And I just find this amazing that you can show this. The effects were very small, right? So in general, participants were quite good at this task and the effects were small. But I still find it interesting that comparing the groups, it was visible like this. Yeah.
So it speaks to the power of the brain mainly here, right? So it's really the framing you gave to the participants really had an impact, albeit small, on the cognitive performances they had. Is that a correct interpretation on my end?
Yeah, exactly. Kind of like a placebo effect. Yeah.
Right. Yeah. Yeah, that's fascinating.
Yeah.
And so, so there are 2 roads I'd like to explore here. First, what do you make of that? Like, what are the implications of this research, especially in psychology, and now that you're going to work in a clinical environment, which implications does it have, if any?
Yeah. I would say mostly worrying implications, because if we again think of advertisements, and see that a statement like this, it was really like 3 sentences or so that participants read, that this can already have an effect on behavior. I find it a bit worrying, especially with a topic so important like eating, right? So I think we should be very careful with advertisement in the food context. And also, I think it can also be leveraged in a positive way. So imagine you recommend someone to do intermittent fasting for health reasons. If you frame it positively, then maybe just this positive framing already has a positive effect on the individual as well. So I think it can be helpful in the therapeutic and in the health recommendation context as well.
Yeah, that makes a ton of sense. I actually have I have to listen to an episode of a podcast that I listen to all the time, which is called Econ Talk. And this week, the episode is about eating with intelligence. And the guest is someone named Julia Bellos. And I know at the end of the episode, they talk about exactly these public policy recommendations for food health. And so I can't tell yet what this is about, but that sounds very interesting and related to what you're talking about. And I will put this episode in the show notes because I'm sure it will be relevant to the conversation. But something I'm curious about here is also, what does the model look like for these kind of experiments? What the technical road now? Let's take that one and talk about that. So how does it work to, come up with such a study? What did it look like for you?
Yeah. So in the end, we just used base factors to compare the 4 groups with an interaction model. In the beginning, I actually took the time to kind of come up with a causal model in a directed acyclical graph, generate simulations from it, test the model on it, pre-register it. The final model did look different. I think I just pre-registered linear regression. So I planned to look at the coefficients. In the end, I looked at the base factors. But it was still, I think, good to go this extra route and look at the potential causal relationships there.
Let me show you how to be a good Bayesian.